In this video, we are going to be looking at the difference between statistical significance and practical or economic significance. Right, so far in this chapter, really, statistical significance we've only dealt with in this chapter. And this is kind of when something is statistically significant when we essentially reject a null hypothesis. All right. So when we are doing our hypothesis testing, we are looking for, a statistical difference between two values, right? Is one statistically higher than the other, so on and so forth. All right. So when we reject a null hypothesis, that is saying our alternative hypothesis is statistically significant. Right? So it's mathematical. It's based on our test statistic and our critical value, and the numbers that make those up. When we are looking at practical or economic significance, we are looking at what's actually happening. Right? We're taking the context of the entire situation into account. So some things can be statistically significant, although they are not practically or economically significant. All right, so I'm going to give you an example, and then we're going to just kind of an anecdotal example, and then we're going to work through a sample problem. Right, when I was in grad school, we would have other economists come in and present their research, and there was one time where somebody was, I don't remember the exact details, but somebody was presenting something, and one of their figures was extremely small. And it was like, for, a percentage change in one variable, what would be the increase in a stock price? It was something along those lines. And the effect that he was trying to tell us about was statistically significant. But the change was so small, especially in what he was looking at, that in all, practical matters, it's not really significant, right? It's not, it doesn't really change things, even though it is statistically significant, right? A lot of the times the way that happens is having a very large sample size. As you increase that sample size, you're more and more likely to kind of reject a null hypothesis if it is false. But again, we can't have these statistically significant effects that are not practically significant, right? Not economically significant. All right, so for an example, all right, let's say that you work at a place where you are making deliveries, all right? And you have a boss that is really hard on you, and they think that the trip should take no more than 30 minutes. Just say 30, I'm going to say 20. All right, so the boss thinks that this trip should take no more than 20 minutes, and this boss believes that you are messing around. All right, so thinks you're slacking off while you're doing these deliveries, right? Maybe, I don't know, going around, hanging out with people, just not doing your job, right? Taking more time than it needs to get back to the main office. Also, your boss doesn't tinks anything, he thinks it. Right? So he thinks you're slacking. And so he records the time it takes you to make the trip the next 30 times you take that trip. So the next 30 times you go out and make this delivery, that boss has a stopwatch, and they are recording how long it takes you to make that trip. Right? So once your boss has collected this data, they get a sample mean of 20.1 minutes, so a standard deviation of 0.05. We don't really need to write minutes. That's what we're talking about. We already know that. Right? And your boss is going to perform a hypothesis test at, what did I write down? At 5%. Right? 5% significance level, 95% confidence level. Right, so we need to set up our null and alternative hypotheses. Right, we're at that point. So your boss thinks you're slacking. Right, so essentially what we can say, right, is that the true average of trip length, right, the true average of how long it takes you to complete this trip is greater than 20. Right, you're taking more time than is necessary to make this trip, right? And so that means the null hypothesis would be that mu is less than or equal to 20. Right, so we can get our test statistic, or excuse me, our critical value. I'll always do that. So our critical value. So looking up here, which one do we need? Are we going to use Z? Are we going to use T? In this case, we are going to use the Z distribution. And that is due to the fact that we have a sample size that is greater than or equal to 30. So our central limit theorem kicks in, right, and we can use our standard normal distribution. All right, so this is a one-tailed test, so we are not going to divide that alpha by 2. All right, so Z 0.05, we can look that up in our table. But we're going to find that it is 1.645. Once again, we could go ahead and set up a little distribution. Then put in our critical value. All right, so we'll put our critical value in right here, 1.645. Then we can calculate our test statistic. Alright, so our z-stat, again, we're just going to plug in, chug in, put our sample mean in, subtract our arbitrary constant from it, divide by the standard deviation divided by the square root of the sample size. Right? Once we put that all into our calculator, we're going to get 10.954. That is our test statistic. Oh, I did not finish doing this, did I? All right. Didn't actually give us our full rejection region. All right, so here we can see that our test statistic, 10.945, falls into our rejection region, right? We're doing a right-tailed test, so if our test statistic is greater than our critical value, as it is here, then we are going to reject the null hypothesis. So that is our conclusions, right? So we're going to reject the null hypothesis, right? And we're going to conclude what? We're going to conclude that the alternative is true. And the alternative is you are taking longer than you should on deliveries. All right, so we saw that the time it took, the average time you took based on that sample was was statistically significantly greater than the time that your boss thought it should take you. Right. However, as you probably noticed, the actual time, right, that average was only 20 minutes, right, or 20.1 minutes. Right, so 0.1 of a minute, so that's 6 seconds. So there's a difference of 6 seconds a difference of 6 whole seconds between the observed average, right, our sample mean, and the hypothesized mean, right? So that's not really that significant, is it, right? If your boss were to try to use this hypothesis test as reason to say fire you, you're taking too long, you're not doing your job, so I'm going to fire you because I've got this hypothesis test that states, right, that shows that you are taking too long to make these deliveries. Right, well, that wouldn't really be fair at all because, again, that is a 6-second difference, right? In the context of what we're looking at, we found a statistically significant effect, right, or a statistically significant difference, but in practical terms, right, in economic terms, the difference is not big, right, especially for something in this scenario. So it is important that we not only take statistical significance into account, but we also take practical or economic significance into account when moving forward, right? So once we've done a hypothesis test, what do we do with that information? Well, it's good we've shown, hopefully, statistical significance, but we also need to think about whether it is economically significant as well. All right, that's it for this video. In the next one, we're going to be looking at the relationship between confidence intervals and hypothesis testing. All right, I will see you guys then.